4.3, which is adding and subtracting rational expressions. Adding and subtracting rational expressions. So far, remember, we've simplified rational expressions, but multiplied and divided rational expressions. Now we're talking about adding and subtracting rational expressions. We're going to deal first with same or like denominators. Three-step rule. Keep the common denominator add or subtract the numerator and 3, simplify. So we're going to look at several examples here. Example, and we have negative 1 over x plus 5 over x. Notice that we have a common denominator of x. So we're going to go ahead and keep the common denominator. And we add the numerator, negative 1 plus 5, to give our answer as 4 over x. Example. We've got 2x minus 4 over x minus 2 plus 4 minus x over x minus 2. Again, we keep the common denominator and we add the numerator, so 2x minus 4 plus 4 minus x. Notice that the 4's cancel and 2x minus x is equal to x over x minus 2. Example. You guys know that I do pull these examples directly from the homework. Okay, so you should be able to follow the examples and do your homework with them. 7x squared minus negative 5x plus 7 over 7x squared. So now we are keeping the same denominator. And we have to be careful in the numerator when we're subtracting, because we are subtracting the entire expression 5x plus 7. So we have to distribute the negative here. Negative times negative is positive 5x. And negative times 7 is negative 7 over 7x squared. So the 7's again cancel out. we've got 8x plus 5x, which is 13x over 7x squared. So this is 13x over 7x times x, which means that one of the x's are going to cancel out, and we're left with 13 over 7x. So these are problems that involve the same denominator. Now let's consider unlike denominators. Unlike denominators. For this case, the rules are a little different because we now have to find the LCD. Find the LCD, which is, most of the time the product of the two denominators. To multiply each term by the missing factor, and 3, add, subtract, then simplify. So again, we're going to look at a few examples on how to do this. So example, I have 1 over x plus 5 minus 1 over x plus 7. So we established that the LCD for the x plus 5 and x plus 7 is simply the product here, x plus 5, x plus 7. So what we do here is we write back 1 over x plus 5, and then we multiply both numerator and denominator by the missing factor, which is x plus 7. So x plus 7, x plus 7, minus that 1 over x plus 7, and the missing factor is now x plus 5. So we multiply both numerator and denominator by x plus 5. And that gives us the same denominator for each term here. So we're going to go ahead and keep that common denominator now, which is x plus 5, x plus 7. And it doesn't matter right now which one you write first. Your homework, I might ask, is going to accept either one first, x plus 5, x plus 7, or x plus 7, x plus 5. So we have 1 into x plus 7, which is x plus 7. And here we have negative 1 into x plus 5. So negative 1 times x is negative x, and negative 1 times 5 is negative 5. Cancel, cancel. And this gives us 7 minus 5, which is 2 over x plus 5, x plus 7. Example, 2 over x squared plus 5 over x squared plus x. So we can't divide x squared into x squared plus x. So once again, the LCD is x squared into x squared plus x. We now follow the process of multiplying each term by the missing term from the LCD here, which is x squared plus x over x squared plus x plus 5 over x squared plus x over x squared. And that process gives us the same denominator, x squared into x squared plus x. So we go ahead and add our numerator. We distribute 2 times x squared is 2x squared. 2 times x is 2x plus 5 times x squared is 5x squared. And collecting like terms here, we've got 5x squared plus 2x squared is 7x squared plus 2x over x squared into x squared plus x. So at this point, we're tempted to think that the problem is done, but notice that there's a common factor in the numerator. The common factor here is x, so we can factor out the x. And that leaves us with 7x plus 2. Over x squared into x squared plus x. So we can go ahead and cancel one of the x's with the x down here. And then notice we can also factor out an x in the denominator right here. We can factor out x from x squared and x and get x squared times x into x plus 1. Okay, so that makes it easier to go ahead and cancel out the x's. And that leaves me with 7x plus 2 over x squared into x plus 1. Example. So I have to solve for x over x squared minus 25 plus x over x plus 5. This can be written because we have a difference of squares here. So this is 4x into x plus 5, x minus 5, plus x over x plus 5. So what we've got here is x plus 5 is already common. X plus 5 is already common, so the only thing that we would need to do here is multiply this term here by x minus 5 to get us to get the denominators to be the same. So we've got 4x, x plus 5, x minus 5 plus x plus 5. And at this point, we can go ahead and multiply both numerator and denominator by x minus 5. And we now have the same denominator. We now have exactly the same denominator. So the job now will be just to simply go ahead and keep the same denominator, x plus 5, x minus 5. And on the numerator, we have 4x plus, and we can probably go ahead and distribute here. X times x is x squared, and x times negative 5 is negative 5x, which simplifies to 4x minus 5x is negative x. So this is x squared minus x over x plus 5, x minus 5. Now, there's a lot of discussion on if we should factor out x in the numerator, but factoring out x in the numerator would not serve any purpose, because it will not cancel with anything in the denominator. So this is a great answer. Now, one final example. So I've got, keep using a star instead of writing example. Example, this is 1 over x squared plus 4x plus 4 minus 1 over x squared minus 3x minus 10. So we're going to have to go ahead and factor here to get the LCD. So we're going to rewrite this as x plus 2, and x minus 5, x plus 2. Be careful with this because x plus 2 is common one time. So when we're writing an LCD for this, we take out that one common x plus 2. Then we have an x plus 2 and an x minus 5 remaining. So we would have to multiply the first one here by x minus 5 numerator and denominator. And this one, second one, we would have to multiply by x plus 2 to get this common LCD here. So let's go ahead and do our fix on this, okay? This is 1 over x plus 2, x plus 2, x minus 5, x minus 5, minus 1 over x minus 5, x plus 2, and here we're going to multiply by x plus 2 over x plus 2. So now we have achieved exactly the same denominator for both. And we can go ahead and write back that same denominator, x plus 2, x plus 2, x minus 5. That's the common denominator. And we make sure that we distribute correctly here. 1 into x minus 5 is x minus 5. And then we're distributing negative 1 here. So this is if I want to write this on the side here, this is negative 1 into x plus 2, which when we distribute is negative x minus 2. So negative x minus 2. Notice that the x's are going to cancel out, and that leaves us with negative 5 minus 2, which is negative 7 over x plus 2, x plus 2, x minus 5. This is a great answer here. You can also revert back to foiling this out, but I think this is a great answer for this question.